Afternoon with us after we know you've had a long day. We welcome you to our NCTest Scientific Calculator, our embedded calculator webinar for this year. Our focus for today is on the scientific calculator, which is what we embed for our assessments for middle school, so 6th, 7th, and 8th grades. My name is Beth Nash. I am a test measurement specialist, and my areas of focus are middle school and high school math and science. So as North Carolina educators, your kids take assessments like the EOGs or the check-ins, and that is what I spend my day today working on. My contact information is here if you ever have a question, and I will also share it with you again before we leave. Before we turn it over to today's main event, I do have a few quick things to share with you. Everyone's defaulted due to the size of the webinar. We are expecting just under 200 folks today. We are recording, and that a recording will be emailed out to everyone who registered. So whether you logged in or you did not log in, as long as you registered, you will receive the email. The email will have the recording, and it will also have all of the links that will be shared as part of today's presentation. The email will come from North Carolina Public Schools, so you may have to look for it in your other folder, but you will be receiving that probably late today. Today's featured calculator is the scientific calculator. We also have an agenda and a slide deck for you. Once I stop talking, I will drop all of those links into the chat for you to click on. And one last commonly asked question, there are no CEUs being offered by DPI for today's webinar, and that's either watching it live or watching the recording. Again, we do have quite a few folks that will be with us today, and so for that reason, we ask for your help in communication. There are two different ways you can communicate with us. You can use the chat or you can use the Q&A. We're going to ask that you use the Q&A if you have content-related questions that you would like our presenter to answer. Nolan will be stopping periodically, and we will go back and answer as many of those questions as we can. If they're super easy questions, I can click on them and then just respond there in the Q&A for everyone to see, but we will have time for questions as we go throughout. We're going to ask that we reserve the chat feature for sharing links, which I will do throughout the presentation. And also, if you encounter technical difficulties today, if you would send a private chat to Stephanie Boyd, she's with us here today, just solely to help us with tech support. So if you're struggling to hear or you need any other kind of tech support, reach out privately to Stephanie Boyd and she will get you up and running. If you've been in North Carolina for a while, you are probably familiar with NCTest. NCTest is our online platform that we use to administer all of those state-created assessments. So the North Carolina check-ins, the North Carolina check-ins 2.0, end-of-grade tests, as well as end-of-course tests. And based on feedback from people across the state in webinars just like this one, we have an exciting addition this year. We have the ability for students to enter in mixed numbers as responses to numeric entry items. This is the link for the website. This is available immediately for all online testing, for all grade levels, and for all of those different products that we produce, like the check-ins, the EOGs, the EOCs. This is just a screen grab of NCTest. It's probably familiar to you. We put it here just to show you real quick. This, of course, is a sample question. It's very easy. What is 1 plus a half? And in the past, we would have asked that students enter in 1.5 or maybe 3 halves or some other similar improper fraction. We are so very excited this year based on feedback that we are able to allow students to enter in mixed numbers. So again, this is immediately available. You can have your kids practice it in the tutorials, but we are super excited and we hope you will help us get the word out that this is a new feature this year. Also, a little bonus, you may notice that we have more than just the yellow highlighter. This year, also based on feedback from teachers across the state, we're excited to offer 3 colors of highlighters. I know when I was in the classroom, I would have kids color code things. And so if that's something that you regularly model, know that that will now be available on our state created assessments as well. I did do a screen grab of this slide, and when I send the email out late today, this slide will be included if you'd like to share it with others in your building to let them know about the new enhancements we have for the online testing system. And with that, I'm going to stop talking for a little while. I'm going to turn it over to Nolan Doyle with Desmos. And I'm going to start dropping some links in the chat. Again, we encourage you to put questions into Q&A. And if you need technical support, please send a private chat to Stephanie Boyd. All right, Nolan. I'm going to pass you the baton, and you should be good to go, sir.
All right, thank you so much, Beth. I'm excited to be here. Thanks for having me. Thank you to all those that are attending. We're gonna see a lot of Desmos. We're gonna see a lot of math, and you're gonna be able to experience those things with me this afternoon. So again, my name is Nolan Doyle. I am a classroom teacher just outside of Richmond, Virginia, so not too far from you all. And I began using Desmos in 2012. So I've been using it for quite a while. And so what I hope to bring in this presentation to you is a lot of those kind of real classroom experiences and kind of what it looks like within the context of the classroom. This isn't just going to be kind of here's a nuts and bolts of how to use the calculator, but what does it actually look like in the classroom? How do we use it instructionally? And also bring some of the knowledge I've gained from being a Desmos Teaching Fellow since 2015 and working towards becoming a certified presenter. So that's a little bit about me, a little bit about Desmos. Desmos believes all students are brilliant, and it's our job as teachers to tap into that brilliance to help students learn math. Desmos Studio wants to build a world where students' access to the power and beauty of math doesn't depend on their place of birth, race, ethnicity, gender, or any other aspect of their identity. They're all about accessibility. And when we talk about accessibility, we can talk about, first of all, the fact that everything you see today is going to be free. So the calculators that we're going to look at, those tools, as well as the classroom activities that are now part of the Amplify education, those are all free and available to you and your students to use as you wish in your classroom. The other thing is I love about that accessibility piece of it is it's the accessibility to the beauty of mathematics and the power of mathematics. And so really the focus is the math, it's not the technology. The math is what leads, the technology is what follows and supports that math. We don't want our students spending so much time on learning the buttons to push and the answer getting. But we want to use these tools to support students as they learn and understand the math on a deeper level. The Desmos company is also guided by specific equity principles and pedagogical philosophy, which we invite you to learn more about on our website. So today's agenda, the bit.ly that Beth has probably, I think, put in the chat and that continues to appear on the screen here, has our agenda in a Google Doc that's yours to save, and you can make your own copy, bookmark it, whatever you want to do to keep, because there's tons of resources that I'm going to leave you with, and I'll reference those throughout our presentation today. But when you open that Google Doc, a few of you are already in there, you can see our agenda. We'll go finish up these introductions and jump into, let me change that right there, not the four function, but the scientific calculator in North Carolina. And then I'm going to get to what I think is the really fun part, is using that calculator and even the graphing calculator too, instructionally, and then using the Desmos classroom activities. Okay, so yes, we've got this great tool for kids to take tests with, but what does this actually look like instructionally? How can you use this to help your students every day better learn the mathematics? We'll leave some time for questions at the end. Also, as Beth mentioned, you can throw those into the Q&A, your questions at any point. It's actually been working well. We did the elementary one yesterday where we kind of stop every now and then and hit those questions as we go instead of maybe saving them all towards the end. So as they come up, feel free to throw those in there. And I'll be referencing these links and resources that are on the second page as we go through today. What the learning goal is not is to become an expert, right? We do not have a ton of time here today, but it's going to be more of a what can, not a how to. So I want to get you inspired, hopefully, to see what can Desmos do in your classroom, and then leave you with those resources to kind of work the how to at your own pace. I'll be showing you some of those how to's, but it's going to be a lot of stuff. It's going to be sometimes, depending on your level of experience with Desmos, maybe a little too fast. But hopefully the resources that I'm leaving you with are going to help you with those next steps to support you as you continue to learn and use Desmos more with your students. So I'm going to jump right in to just an overview of the tools, and we are going to focus on that scientific calculator to start. So if I head to desmos.com, and the landing page is here, and if I go up to math tools, I can see all the different tools that are available to me. So I can pick that scientific calculator, and there's the public-facing scientific calculator. But what I want to do is I want to show you the calculator that is specific to North Carolina. So instead of going to that math tools menu, one thing we can do is we can go to assessments. And I'm actually going to have direct links to all these things that I'm navigating to right now, so you don't necessarily have to remember all the places I'm going. But as we go to assessments and I scroll down, I can see all the states that use Desmos on their end of course testing, and I'm going to find North Carolina. And there I can get the different versions of calculators that are specific to North Carolina, as well as this PDF, which will summarize those differences. So when I click on that PDF, I'm going to jump down to scientific. And the nice thing, there's only two differences. The one thing that is disabled is defining functions. So I'll show you what that means in just a minute when we explore the calculator. And then also the keypad, instead of a QWERTY keypad that you would see in the standard calculator, your testing calculator is alphabetical. So I'll show you what that looks like as well. So I'm going to go back and click on the scientific calculator. And now you'll notice the green band at the top. So I know that I'm in the North Carolina version versus just the plain standard calculator. So I'm going to keep those side by side in my tab because I'm going to compare a little bit. And so these links that I just went to, the PDF and your specific scientific calculator, I'll just show you, those are linked in our agenda right here that I highlighted for you. So this would first highlighted one will take you to that PDF. And then that second one will take you to the North Carolina Scientific Calculator Simulator, which is the one with that green band and says NCTest version. All right. So just looking at the calculator and going through, I can start making some calculations. And as I go, you'll notice I'm hitting the enter key to go to the next line, but it's already producing an answer. That's one thing I like. Like, students don't have to hit that enter key. They can start to see the answers as they go. So it's updating every time I enter in different things here. You'll notice when I hit that division symbol, it automatically went to the fraction bar. So that might be something that's a little different than scientific calculators you worked with in the past. Another thing I like is that I've been clicking just with the on-screen keypad. I could also be entering things in from my keyboard, so I don't have to use that. So depending on what you're comfortable with or what device students are working from, you can use the keyboard or click on the screen. Another thing here is the main tab. So you've got a few different operations and functions to work with here. When I go to ABC, that's where that alphabetical keypad is, and you can see that's in alphabetical order instead of the QWERTY or what you would see on your keyboard. So that was one big difference. And then one other tab that students might need to navigate is the functions. And so you can see the different functions that are available from that tab there. With my calculations, I can also reference the answer from the line above. So if I hit that answer button, it will bring that -8 in and I can continue to operate. I like that it actually shows the number it's using. So it puts it in, doesn't stay just ANS. And I can hit enter and then I could maybe use it again. I can also just type in ANS and it will now bring the previous line's answer there. Not only can I view those previous lines, but I can go back and actually change them. So I love that everything's still there and I can change and just continue to get those operations and results in those lines without having to bring it back down here. And so even with that answer one, right, if we change that, it will change the answer automatically here. A few other things, I can clear out a line at a time, and then after I clear out that line, it gives me the option to clear the entire calculator. There's also where I can clear just one thing at a time, this X and backspace here. These arrows right here are my undo, and if I go too far, I can redo buttons. And then finally, I wanted to show you the defining a function. So I'm going to go back, since it won't work in this calculator, and show you what it looks like in the standard calculator. If I have a function f of x, I could define it in the standard calculator and hit enter. It's not giving me any result over here, but then I could maybe use the function notation like f of 5, and it gives me that result over here of 10. If I try to do that in the North Carolina version, I'm going to get an error message off the bat, right? I have too many variables, so right now it's saying you have f and x. But if I keep going, that error message turns into this feature is not available in the current calculator. And one other thing I wanted to make note of that's a little bit different is the percent button. So maybe a little bit different than other calculators with the percent. So we can take 45%, it does percent of, and then we can kind of play around with what we put after that. You'll also notice as I get an answer that's a decimal, I can toggle back and forth right here to convert to a fraction or back to a decimal. So we'll remain in that improper fraction. It won't put it in the mixed number for us, but we can go back and forth between the decimal and the fraction. All right, I think I'm going to pause there before we get into kind of the instructional uses of it and just make sure and check in with Beth if we had any questions come up as we're looking at just the basics of the scientific calculator, some of the functions and the differences between the North Carolina version and accessing it compared to the standard calculator on the Desmos website.
Thanks, Nolan. Currently, I've been able to handle all questions in the Q&A. They've been more geared towards North Carolina testing more than the calculator. We did, hang on, my chat just popped. We do have function would need to be used in the graphing calculator then. Function.
Maybe the defining the function, so you couldn't use it in the North Carolina one. I'm actually going to show you you could use it instructionally. You could just use the standard scientific one if you wanted to make use of that function. I don't know if that's what they're referencing.
Yeah, I'm thinking maybe that was it. And other than that, we are good for now.
Awesome. All right, so going to kind of shift a little bit and get to what I think is the really more interesting stuff is how do we use this instructionally? And so when we think about this, or when I think about it, I always like to think that when we saw all those states that are adopting Desmos on their end of course test, they're not adopting it because it's the best tool to take a test. They're adopting it because it's the best tool to learn and understand math with. And so when I see more and more states adopting it on that test, I get excited, not because it's on that test, but excited because it means more teachers have the opportunity or are going to use it in their classroom instructionally, right? So if that's the tool we're using to learn, then we can throw it on to the assessment at the end as students are demonstrating what they've learned. So when we use it instructionally, I want us to think about the verbs. What can we do with this tool to get students doing these things, right? We don't want this tool to be something that replaces student thinking. We want to push student thinking further. And so we can do that by getting students making predictions. We can invite students' informal knowledge before the formal knowledge. We can get them noticing patterns. We can identify and build structure together with our students. instead of just telling them, hey, this is what it looks like. And ultimately, we can get them connecting representations, especially as we go from that scientific calculator to the graphing calculator. So that's what I'm going to show you. So think about those verbs and what we can do in the ways that I demonstrate the calculator is being used, what students are actually doing. So before we get to the classroom, we're going to go back to the scientific calculator. I'm actually going to use that function notation. So yes, this is not something students can do or use on the test, but I think it's a really powerful way to introduce the topic of function notation, right? So if I'm introducing function notation, I might start that class by inviting students to notice patterns, right? Maybe make some predictions, okay? And start to generalize what's going on. A lot of times with the technology like this, I like to kind of use the technology to start and kind of ask the students, okay, what's the calculator doing? So maybe they haven't seen function notation and so before, and I just start entering in this f of x equals x plus 3. And I start putting in f of 5, f of 4, 3, f of 2. And I just invite them to share what they notice. And I can also make this display a little bit bigger. So if I'm projecting this for students. And so they've got this on the screen and I might just ask them, what do you notice? What do you wonder? And so really low floor, like just tell me anything you notice. Like, and maybe they've just noticed the numbers are going down by 1. Right? Maybe they notice the difference between these are all 3. Right. And so we can continue, we can start to have that conversation and questioning and having students share those observations and noticing those patterns. And then maybe have them make a prediction. What if I put in f of 1? What's it going to be? Right? What if I do this? And maybe I even put in this little mark here so that it gives an error. So it doesn't give me the result. And I say, okay, someone predict what's going to come next. Right? And so hopefully they'll say 4, right? Or maybe I come back up here and I want to change this and we start going outside of that pattern. So what if I do 15? Can my students predict what's going to come next? Or they give me a number. Someone give me a number to put in here, right? So you can engage them to kind of slowly build what's happening is it's taking this value here and adding 3. And now we can start bringing that formal language back in. We can start saying, okay, so this number is the input, this number is the output. And we go from their informal observations to the more formal notes that maybe we're going to take in just a few minutes. If we want to level that up a little bit, let's go to the graphing calculator. So we had our f of x equals x plus 3. And we started getting, all right, f of 5, f of 4, f of 3, and all of a sudden we can start saying, we said this was input, this was output. Well, which variable is the input? That's x. The output's y. How do we write an x and a y together? Well, we can put it as a coordinate pair. 5, 8, 4, 7, 3, 6. Maybe we move our graph around and we start to notice those are all the points that are going to make up this line. So now we've introduced this new notation to them, and it's not just me telling them what this notation is, it's them kind of discovering it on their own, or maybe with some facilitation from myself and the questions that I'm asking them and what I'm showing them in the calculators. And then we're able to connect, right, the algebraic, the numerical, and the graphical representations all on one screen, which I think is super powerful and helpful for students to make those connections. So this is just kind of one example of how we can really make use of the tool instructionally to not just work problems, but introduce a topic and make sure students truly are understanding that topic and make those connections with them. Another thing that's helpful is we can define some variables in the calculator as well. So I know for my students, they always struggle with something like this. So like a squared times a cubed. And I'll get some students that will say it's this, some students that will say it's this. And so what I like to do is have that discussion, right? So if I'm seeing this mistake, we'll kind of stop, I'll put this up on the board, like I'll bring the calculator just like this and say, okay, well, what's the answer? Which one is it? And so hopefully someone will justify it by saying, well, a squared is this, and then you're going to multiply it by a cubed, which is a times a times a. Right? And say, okay, well, does that make sense? Hopefully that makes sense. But also, we can define a variable here. What if a is 4? Well, now all of a sudden, that expression is being evaluated. And we can see clearly which ones are equivalent. Right? These are equivalent. We can change that value. These values change, but the ones that are equivalent don't change. And so all of a sudden, we can use this to have a really powerful visual and conversation about equivalence, which I think gets lost in all these rules and procedures that we throw at, especially as we're getting into the algebra. That's also helpful. We have a variable defined, maybe just the difference between a times a. So I'm going to clear this out actually. A plus a, right? Like which one of those is a squared? Which one of those is 2a? Well, again, let's define what a is, and we can see which ones are equivalent. Which ones are equivalent. And it works for any value. That's why we're able to rewrite these expressions. That's why these expressions are flexible in the way we express them and simplify them, right? We throw that word around all the time. We're just writing that equivalent expression. This works really well in the graphing calculator as well. What I like about in the graphing calculator is if I do that there, let's do the a squared times a cubed, we can add a slider. So as I wrote the a's, it's like, hey, that's not an x or a y. What's going on here? Would you like to add a slider? So I don't have to define it. It will define it for me. And it gives me this slider here where I can change the value very, very quickly. So then I could compare a to the 5th, a to the 6th. And we can even go hands-free mode and hit play and just stop at any point. And we can see which expressions are equivalent. Right? So we don't want our students to kind of lean on this maybe for doing the math for them, right? But we can really present it in a way that I think is powerful in helping them deepen their understanding of equivalence and different equivalent expressions. One other thing, maybe two, we'll see how much time I can get through on this. With sliders, we can add the sliders to something that we're graphing. So this is actually what really got me sold on Desmos in the first place. So I'm going to do M and B. Again, just like that A, it's saying, well, we don't really recognize those parameters or variables. Would you like to add some sliders, right? We need some numbers in there. So let's assign some numbers to M and B through the sliders. So right now it's graphing where M is 1, B is 1. Great visual, and now a great dynamic visual. So if we're learning about slope-intercept form, we can throw this dynamic visual up, invite some informal observations. What do you notice? What do you see? Right, so any kid can answer that. What do you see? The line. It's moving. How is it moving? What's changing? What's not changing? Right, so all those questions, we can start to spark some observations from our students. And so hopefully something that will come up is the idea of the direction is changing and the steepness, right? And they might describe it in their own words, in their own informal language, and we can start driving them to the idea of slope and what slope tells us about the line, the direction and the steepness. We can hit pause and then change the B. Some students might say the line going up and down, left and right. It kind of depends sometimes on the slope. A little deceiving how it's moving, right? But those values are changing. We can even pause and do a quick click. So easy to get those intersection points that just pop up, and we can start to connect again the graphical, numerical, algebraic representations, and we can start to see the connections and get a bunch of examples at once. That's the power of the technology, right? Those great visuals, the dynamic visuals, The idea to get a bunch of examples at once so students can start to predict and make connections on their own. All right, I'm going to go ahead and stop there as far as using the calculators for instruction. And maybe just stop real quick and check in with the questions as well.
All right, so far, again, I've been able to handle the Q&A. They've been more focused on things more related to North Carolina testing. So I think we're good for you to continue on, sir.
Great. All right, so we've so far looked at the calculator version scientific for the North Carolina version. And then also hopefully spark some creativity and some inspiration a little bit of how you might use the scientific calculator as well as the graphing calculator to help your instruction, right? Support your instruction as students explore and discover some of these concepts and topics that you're teaching. Now what we're going to do is jump into Desmo's classroom. So we're going to go through an activity that I put together. It's a few screens from two different activities actually. And we'll go over, if you're not familiar with Desmos, kind of where these activities came from and a little bit of the basics of setting them up towards the end. But right now, I want you just to keep that kind of student perspective. So just go through this activity kind of like the student, think about what you're having to do, again, those verbs and things like that. And I'll model the teacher end before kind of coming back and showing you more of the nuts and bolts of that teacher perspective. So what I'm going to have you do is jump into this activity. So here is the class code, and I'm not sure Beth might be able to throw that direct link into the chat for you.
It's in the chat if folks would like to click.
So you can enter into that activity. Actually going to keep you on that first screen. So as you enter, you'll be restricted to the first screen, and we'll just kind of go over. You can see this is a link to the full activity if you wanted to go back and use this activity. Even if it's not a topic that you teach, again, just think about the benefits of using an activity as we go through it. What are students able to do that they might not in a traditional paper and pencil activity? What am I going to be able to do from this teacher dashboard that you gives a real advantage to an activity, maybe again, just with paper and pencil? All right, so let me see here. All right, so if you look at my screen first, what you're going to do in just a second is you're going to hit that button, try it, smash that try it button, see what happens. We've got shear the sheep, and we're going to see what happens based on what we enter in here. And then I want you to try out different inequalities. So change what's in this box here, type in whatever you want, and then hit try it again and see what happens. Okay, so you're just going to explore. And you're just going to try to see what's going on. See what happens. Try different types of inequality symbols as well as different values. All right, so I'm going to go ahead and move you to screen 2. So go ahead and take a few minutes and play around with screen 2. If you're not able to get into the activity, maybe you're joining us, on your phone, it's a little small, or you're just somewhere where you can't really open up another tab. I'm just going to play around on my screen so you can focus on that while the others are exploring and playing on their screen. So maybe about 30 more seconds to play around with that screen. All right, I'm gonna pause you in 3, 2, 1. All right, so you should no longer be able to interact with your screen. If you go ahead and bring your attention back to my screen, just go over a few things that I'm seeing from my perspective and things I'm able to control as students, as you all were working as students through the activity. So this is what's called the teacher dashboard. I can see all the students that have signed in on the left. You may notice these are actually not your names. These are your fake mathematician names. So what I can do is I can toggle back and forth with the anonymize tool in the upper left-hand corner here. So I can see the students' names, or I can give them their fake mathematician's name. So what that helps me do is as students are working, I'll see their names. I can see what screen they're on in this summary view. I can see which screens they've interacted with or they haven't interacted with. So who might need a little bit of help going through that activity. Um, when I'm ready to maybe display some student work and display this in front of the class, I'm going to go to the anonymous mode. So these are assigning these random, or not random, these have been selected mathematician names, but they are assigning them randomly. And what's kind of cool is the students will be like, well, where are these names from? And they'll go and they'll Google them and they'll learn something about these mathematicians and what they maybe contributed to society. And as I'm at this summary view, I can also toggle back to some of the other views up here. So the student view was what I was using while you were working to show those that maybe weren't able to get into the activity or wanted to explore on their own. This is what the students will see. So a lot of times this is where I'll go to maybe even just give directions before I let them jump into the activity. Or maybe there's one I wanted to try that students didn't. So I might have directed them, well, did anyone try, less than or equal to 10? Did anyone try just less than 10? And what does that look like? So I could display that up here kind of as the student. The other view is the teacher view. So this is super helpful. I can see each student's graph as well as their responses that they're entering. So as you were entering these in, this will update. So I can see a lot of students that have entered things in or what they've entered in last. And I might find some interesting ones to compare. So just as I'm looking at the dashboard now, this is what I might highlight while students are working. Say, you know what, I want to talk about this and talk about what's similar, what's different about these. And maybe we can have that great conversation that these actually mean the same thing. And we can also show the animation to prove that they mean the same thing. And that's a really powerful thing that happens sometimes where these types of things, instead of just telling students, hey, we can put the X over here, or if we put on the X on the other side and flip the inequality, it's saying the same thing, right? But this comes up more organically with the students actually entering them in. So that's usually a little more powerful. So this is where, again, I'm kind of glancing over student responses and trying to see which ones I might want to highlight and go over as we look. And this is, oh, look at this one, right? We could get students to predict, okay, what's going to happen here? I actually didn't even think of doing this, and I'm not sure what's going to happen. So it's another cool thing. I get surprised when doing these lessons. Oh, just sits right there, right? So mathematically, that makes sense, right? X equals -10, just right there, right? We're not going to go less than, we're not going to go greater than. Very cool, very cool. Love that. All right, so you got the idea of what the dashboard looks like a little bit. We've got our summary view. I can get a quick glance of where students are, especially if I'm pacing them to multiple screens. I can see who's out ahead, who maybe I need to slow down, or maybe who's behind and I need to give a little bit of a nudge as they're going through. Teacher view, I get some more details. Again, maybe who needs help, who my high flyers are, but more importantly, which ones do I want to display? Which student work do I want to celebrate? And with this type of activity, there's really no right or wrong answer to start here. Just some interesting things to play around with. Student view, I might use that to get the things running and show students what it's going to look like, or display some of my own examples that I wanted to go over. We'll talk about snapshots in just a little bit. What I'm going to do now is go ahead and let you continue working through the end of this activity, as well as explore maybe that last activity too for a few minutes before I stop you. All right, so take a few minutes, continue navigating through a little bit more of the shear the sheep activity. And then also there's a marble slides activity. If you're not familiar with marble slides, play around with that. I'm not going to give you any maybe direct instruction of what to do there. And just play around, see if you can figure out what to do on those screens. And we'll come back again in maybe just 2 or 3 minutes, not a ton of time, but a little bit of time to play around.
So Nolan, as folks are exploring, we have, and it was, so Steph had to leave, but she passed a message to me from Rick. Rick, I'm not sure I understand your message. I'm going to try to unmute Rick and let Rick ask his question directly to Nolan. All right, so let's see if we can make this happen. All right, Rick, I believe you're unmuted if you'd like to ask. So Rick Rutledge, you had a question about rotations. I've unmuted you if you would like to ask Nolan about that. All right, well, that is okay too. Oh, no, he put in the chat and he didn't have a question. All right,
Okay.
very good. That's what we're looking for. Want to make sure everything's been answered.
All right, we can do about maybe 1 more minute to explore. And then we'll wrap up a little bit. All right, I'm not gonna pause you this time. I'm gonna leave the activity open if you wanted to explore. But if you look back at my screen, just kind of debriefing a little bit. These were only 3 screens in the larger activity of Shear the Sheep, but the format of this activity and a lot of other ones is in Desmos is very, very similar, where there is this time to really just explore and give interpretive feedback more than evaluative feedback. So like that first screen, when we're working with Shear the Sheep, it's not a direct like check mark or X, like you're right or you're wrong. You're exploring with it, right? And so as you're going, it's interpreting mathematically what the student is entering in, right? That's the feedback, right? You're able to see, okay, this is what X less than 10 means mathematically in this context. And we can compare that to what X less than or equal to 10 is interpreted as mathematically. So that idea of interpretive feedback over evaluative feedback, it's, a lot of the technology we may be using in math class sometimes is these problems with one correct answer, you're right, you're wrong, and it doesn't really push student thinking. So this evaluative feedback where you can kind of try different iterations and really explore and figure out what's going on is really helpful to students as they understand the math. And as we do this, I love the context of being able to talk about including or not including. So in this case, right, we want to include that blade of grass, that one blade of grass there. And that's a nice anchor problem to come back to later in the year, even like when we're talking about solutions, like, oh, remember Shira the sheep when we wanted Shira to get that blade of grass, or when we didn't want Shira to fall off the cliff, right? We didn't want Shira to fall into the water, right? We don't want to include that value of 3, right? So we don't want the or equal to. So that powerful animation and context really anchors in that understanding of including or not including certain solutions. So those are a few things I love about the activities in general and what students get to do and how it's helpful for their understanding. As a teacher, I love this dashboard of being able to see student responses in real time and start to collect them and start to organize them for conversations. So I might like this response here. So I'm going to save this as a snapshot, and I'm also going to save this one. And as I save them, so I could just click on them and display them here, right? We have the anonymous name, we could talk about them. But if I have the time, this is kind of a next level move as you get more comfortable with these activities. Or a lot of times if we end the activity in one class, I might start the next class with some snapshots. But I can put these on screens, and I could put them on the same screen to compare, or I can order them and say, I want to talk about this one first and then this one. So when I pause my students and I bring them back to our whole class discussion, I can start talking about this one first. Well, what actually happened? Where did they get the 10 is less than 70, right? And we can start to dig deeper into that idea. And so I might then move to a more descriptive response here. We're actually substituting in the value for x to see what the answer is. Gets a negative answer, she's to the left. She gets a positive answer, she's to the right. Okay, so different ideas of maybe going off of that and understanding what's going on here. Maybe we can refine those answers as we start to display them as well. The other activity was more of a practice one. So once you know something like or taught slope-intercept form, this is marble slides. So our goal is when we launch these marbles that they're going to hit all those stars. So I need to adjust over here. In this case, I need to adjust the slope and then the y-intercept so that now when I launch those marbles, I get all the stars. And what's really cool is if I go to this one, we can even start bringing in restricting the domain. So it's not that the line has to go through the star, it's just that those marbles have to fall and hit the star. So this is huge for practice. It's not a worksheet of 10 problems where they're graphing. They're coming up with the equation. And they're going to try different things and they're getting that instant feedback. Let me try this and see what happens. Let me try this and see what happens. Let me try this and see what happens. And so that practice is really, really powerful because they're getting that interpretive feedback. When I enter this, the graph interprets it mathematically like this. How do I need to change that? When I do this, it interprets it this way. And so they're making those connections. And this has been a game changer really for domain. Domain and range is always a hard thing for my students to understand. And this kind of gives them a reason to use the math, a reason to understand, hey, I want to restrict the domain. I want to take away this part, or I want my graph to only be this piece. So there's a lot of creativity that comes out in marble slides as well. A lot of excitement too from the students as they're playing this game. So that should give you kind of an example of an activity that would be used more for development and introducing a topic, and then one that's more practice as well. So there's lots of different activities that you can see and use in different parts of your lesson with Desmos. A lot of the dashboard is, or the all of the tools are really designed with the 5 practices in mind. So if you're familiar with that, you might see exactly how that lined up, especially being able to monitor the students as they work on a test, select and sequence those snapshots, or even just going from the teacher view, being able to see which students' responses you want to select and sequence and use to help students make connections. It's really, really powerful stuff. And I love it because it is students' ideas that are at the forefront of my instruction. It's not my own ideas. And just put in a few more examples of what the dashboard looks like and how you might use it. When we ask those informal questions, like just what do you notice? What do you see? We're going to invite a lot of different responses, and then you can display them all in one spot. And I've got them in anonymous mode. So as students were just describing what they noticed, we can have a lot of conversations about, okay, who do you agree with? Who do you disagree with? All of a sudden, we're talking about solutions. Ooh, someone talks about the x-axis. The word it is on the x-axis. I love asking, okay, well, what is it in this case? And then we could maybe bring in the idea of the vertex, right? Or the one solution or the one repeated solution in this graph. So by inviting that informal language, it sparks a lot of different conversations around all their unique answers. And the students are invested because it's their ideas. It's not mine. The dashboard will also group answers that are alike. So in this case, again, the question's not really important, but what this shows you is on the dashboard, everyone that entered in this expression is grouped here with their anonymous name. Everyone who entered this in is grouped here. So I can see the range of different expressions that were entered. And I might ask again, who's right, who's wrong? Are there multiple expressions here that might be correct? And this y greater than 1 would be a really interesting conversation to compare to this 1 is less than y and see, okay, are these the same? Or do we need the or equal to or not, right? Some people were choosing no or equal to, some were. And then we could go back to the problem and really connect that y. So we're going to get students to justify their answer as a class, or they're going to have to justify someone else's answer, argue for it, argue against it, right? But we're getting that mathematical discourse going on in our classroom. This was a sketch. So I love being able to see all the sketches at once. And again, kind of an open-ended question. There's more than one way to be right or wrong, just making some interesting answers. This is interesting, right? Because they enjoy sketching their own pictures, right? As long as they keep it clean, right? We can celebrate some of those pictures that they draw and their creativity. But I also love this one because it only touches the x-axis once. So that's a unique thing that I might highlight and talk about with students. When I talk about this was unique and different. It's upside down. And then we could bring in the other representation, the equation. So what would have to be in the equation to make this upside down parabola? The other thing with sketches is I can look at them individually, but I can also look at them all on top of each other. So this was a problem where they needed to create a perpendicular line with C and the point that they plotted. So these green points are all my different student responses from one class, all on top of each other. And where it's darker, there were more responses. So there were a bunch of responses here and several responses here. And I love this, fits this quote that I saw on Twitter from Marilyn Burns, that a student's wrong answer is most often the right answer to a different but related question. So a lot of times our job as teachers is to think, okay, if this is the wrong answer, what was the student actually answering? And I use this with the dashboard. I'm going to start with this wrong answer here, and I'm going to throw it back to my students and say, all right, look up here, look at this point. Change the problem, change the question so that this is the correct answer. All right, so now I've got everyone thinking, and now they're hopefully going to say, well, just change this word perpendicular to parallel. And so not only have I pushed my students thinking, I've also maybe validated this student who was wrong, that they don't feel so bad. You know what? It was just a mix up in one word, a word that starts with P, right? And then you would have been correct. All right, so we're going to validate that thinking in some way before we move on. We're not just going to talk about the correct answer and make that student feel like they had nothing of value to add to the conversation, right? And then I can talk about all these and we can celebrate that, okay, you knew that the perpendicular line had to have opposite slope, had to go in a different direction. but some of you did not get exactly the reciprocal, right? So then we can dig into the details of the rise and the run and so on. But that gives you an idea again of what you can start to look for. It really, the dashboard really kind of changed my perspective, and that quote along with the dashboard of what I'm looking for and what I'm gonna, highlight and use and sequence when we go over the different activities. So in using the teacher dashboard, we want to think about those different classroom conversation tools. So being able to anonymize and get that student work up there, pacing and pausing. You saw that a little bit today as well. The different views we can make use of. And really all of those things are just about using them to create discourse around student thinking. The student thinking is what we want to put up on the stage under the lights, right, for students to think about. And then we facilitate that and we move them from maybe their informal thinking to more formal thinking. All right, so just with a couple minutes here before I check in for any last minute questions and give you a link to a survey as well, if you don't mind filling out. The teacher.desmos.com, this is where you're going to go to create your account and find the activities. I'll show you what that looks like briefly, but I didn't spend a lot of time on it today because I really wanted to focus on the instructional part a little bit more. And as far as the building piece, I gave you some links to some activities and collections of activities that might be useful to you. And then I broke down down here, kind of building with Desmos a little bit more. So how do you actually create your own activity or edit one that's already there, as well as searching. The teaching with Desmos is kind of the stuff like snapshots, right? You can dig into a little bit more with that, the pausing, the pacing, anonymizing, and things like that. You can dig into at your own pace a little bit more too. Okay, but teacher.desmos.com, that's where all the activities are, where you can do a general search here by topic, or maybe you like marble slides and you could see the different marble slides that are available to you. So what's showing up here is all the Desmos activities that they have created or vetted, as well as the ones that I have either edited or collected of my own. The other thing are the collections. And so these different collections by subject area, by grade level, by topics, give you a nice overview of some that will introduce the topic, develop it, and then practice it. And as you explore those, you can preview them, go through the activity with some nice teacher moves and hints as you go along of how the will actually run, and then you are ready to actually assign it to your class. When you assign it, it'll pop up here with your code, and you can jump into the dashboard from there. So that resource page is going to be hopefully really, really helpful to you as you go back and learn at your own pace a little bit. There is an email, my email, as well as the support email for Desmos at the very, very end. Is the support one. At the very, very beginning is my email. So feel free to reach out as you go back and dig into these resources and start to use Desmos or continue to use more with your students. And I'll sit, we have a couple minutes. I can see if there's any more questions. And while we do that, if there's any, or if you don't mind going to this bit.ly and filling out this survey for us today, that'd be super helpful as we continue to find ways to support you all.
All right, so I have dropped the survey link in the chat so folks can click. We do have one question about where folks can find that resource at. If you could backpedal just a moment and show us again how to get to the resource you showed.
The resources?
Yes.
So this bit.ly in the upper right-hand corner will take you to the agenda, and then the second page has all the resources there.
All right, and that will be included in the follow-up email that's sent out. All the links that have been shared will be included in that email so that you can just click on stuff. I'm seeing lots of thank yous, but no questions. As folks continue to fill out that survey, I am going to share our closeout. If you would, oh, there you go. Let's see. Where is?
All right, I just passed it back to you, so.
Thank you, sir. All right, so again, we appreciate you spending your afternoon with us. We do have some contact information here. This will come out to you via email. As a quick reminder, the email will be sent this late today. The email will come through from North Carolina Public Schools, and it will have a link to the recording and all of the resources that have been shared today. We are very appreciative of your time and of Nolan's time. And with that, Nolan, unless you have anything else, I will sign us out.
Thank you all for joining, and hopefully you got something useful and hopefully inspired to use Desmos with your students.
All right. Thank you, sir. And goodbye, everyone.